This is infrared sensor footage recorded aboard a United States military platform in 2022, running for nearly 8 minutes and showing a small thermal contact drifting against a colder background. The clip was provided by the United States European Command to the All-Domain Anomaly Resolution Office, AARO, as part of a routine report on an unidentified object observed in European airspace. Analysts at AARO reviewed the imagery and produced a formal assessment of the contact and its behavior. The office concluded with high confidence that the object depicted is almost certainly a balloon, estimating at least a 95% likelihood that the contact is a lighter-than-air instrument or envelope, not a powered vehicle. The finding rests on 2 lines of evidence visible here. First, the object shows a shape and thermal signature that is strongly consistent with other resolved imagery of balloons, including a rounded morphology and thermal contrast that changes slowly relative to the sensor. Second, the object moves in a way that aligns with ambient winds rather than demonstrating self-propulsion, drifting across the frame at speeds and along directions consistent with meteorological data for the region. Early in the clip, the sensor holds a steady track as the contact appears and then moves laterally with the scene. At times, the camera or platform pitches, and the contact follows a path that suggests it is carried by the atmosphere rather than actively maneuvering. Over several minutes, the thermal intensity and apparent outline vary in ways typical of thin envelopes catching sunlight or cooling in the upper layers of the air column. The footage is infrared rather than visible band imagery, so the object appears primarily as a hot spot against a cooler sky where cloud field and details of surface texture are limited. That limitation is part of why analysts emphasize pattern matching with previously resolved cases and correlating observed motion with external environmental data. The report accompanying this video explains how experts compared the clip to multiple examples in an imagery library and to model predictions for balloon drift under measured wind profiles. Those comparisons are what drove the high-confidence assessment. The case is cataloged as PR-010 and entered into a broader set of resolved reports where mundane explanations account for the observed phenomena. That cataloging matters because it reduces uncertainty in the wider dataset and helps analysts prioritize cases that remain unexplained. Footage like this is also useful for refining automated imagery filters and human review checklists, because balloons of many types and sizes can produce thermal signatures that initially appear anomalous to onboard sensors and to operators. There is no implication in the assessment that anything other than a benign lighter-than-air object is present in the clip. The material here is representative of a class of observations that often trigger formal reporting precisely because they are unfamiliar to the immediate crew and sensors, yet resolvable after correlation and analysis. The United States European Command forwarded this report to ensure the data were preserved and reviewed by a centralized office with access to cross-domain datasets, and AARO documented the evidence supporting the balloon determination. For viewers, the clip is a short study in how limited electro-optical information can yield uncertain impressions until contextual data are applied. The contact remains small in the frame for most of the recording and does not exhibit rapid acceleration, abrupt course changes, or coordinated behavior with nearby air traffic. Instead, the motion is smooth and sustained, which matches the motion expected of a light envelope subject to winds aloft. The morphological matches noted by analysts include rounded outlines and intermittent changes in apparent size that can occur when a thin surface tucks or billows and when the sensor view angle shifts. Analysts also considered and ruled out sensor artifacts and platform-induced effects before arriving at the balloon conclusion, and the documentation describes those quality checks. Because the case is resolved, it provides a clear example for training and for public understanding of why some UAP reports end up identified as ordinary airborne objects. That process of report submission, cross-checking, and classification is central to how centralized review offices build a reliable record of encounters and reduce the number of truly unexplained items. This file therefore speaks less to extraordinary capability and more to the mechanics of observation and interpretation when an unfamiliar target is detected on infrared systems. The recorded behavior, the analytic comparisons, and the weather-aligned motion together created the basis for a high-confidence determination that the contact is a balloon rather than a powered or guided object. The documentation accompanying the imagery notes the chain of custody for the file and explains how the case was labeled in the archive for future reference and study. For researchers and members of the public who study sightings and sensor behavior, resolved cases like this are valuable because they sharpen criteria for filtering and help identify which signals genuinely warrant deeper investigation. For operational analysts, the episode is a reminder of the importance of pairing sensor footage with contextual information such as wind profiles, flight tracks, and imagery collections of known objects. In short, this clip is part of a larger pattern of observations that, when examined against additional data, align with well-understood atmospheric and human-made objects. That is the conclusion AARO reached for this submission, and the assessment reduces uncertainty about the contact shown while adding to the body of resolved imagery available to analysts and scholars. Explore the wider archive, sighting reports, and our weekly UAP News podcast at uapdrop.com.